So I think this is the last slide we went over. Okay, it shows how a two ration blend can get kind of complex whenever you start playing with like 3 drops of feed or feeding multiple times a day. But this is an example of a transition strategy that's actually used by a consulting nutritionist. I think his name's Jim Simpson or something. But so this is what he has his feed yards do, is large commercial feed yards. Again, if you're going to do a two ration blending system, you need to have a batch mixer so that it wouldn't make sense for you to uh, do this if all you had was just your feed wagon, which is going to be the same feed wagon that's delivering the feed to the cattle in a pen. Okay, so know know the advantages, disadvantages of these two transition strategies, and be able to say what it is that makes you capable of doing the two ration blending system. Okay. Okay. Um, all right. So here's another example. So transitioning to a finisher. In this example, there's an initial large, so a 2 megacal of NEG per hundredweight increase in energy bump. Okay. So in this example, the thought would be this first initial bump, we would need to go pretty much from this to this, so almost 2 megacals increase. But that's just so that we can provide enough finisher to make it worthwhile. Okay, if you're just going to deliver like 5% of that finisher, you may only be delivering like, you know, I don't know. If your drop's 300 pounds, you may only be delivering 1,500 pound or 15 pounds of feed to that pen. Okay, so oftentimes they'll do this first initial ration change will be a lot larger, maybe 10% or 15% jump than what would be typical. Okay, does that make sense? All right. So other important things. So this data is all from the Kansas State Focus on Feedlot data set. Okay. Um, the initial body weight that cattle get placed on feed and the time of year that cattle get placed on feed will have a huge impact on their performance throughout their finishing period. Okay. Heavier animals, so animals that went through like a yearling growing system, they will eat more than calf-fed animals, animals that are placed on feed at lighter body weights. One reason is that if you're placed on feed at a heavier body weight, your average body weight over that finishing period will just be heavier. So they will eat more just because on average during that feeding period, they're just heavier. Okay. The other reason is something we talked about with comparing calf fed to yearling fed systems already. Lighter animals just won't have that capacity to consume feed like a heavier animal. Okay. An animal that's grown on pasture will just have a larger volume of rumen to support more intake. Okay. Now, seasonally, there's a big difference. Okay. So if we look at just these changes in the intercepts, okay, so if we have a December placement, they're going to consume the least amount of feed um, compared to the all other months. Okay, so a December placed cat animal is going to consume less feed than animals placed in any other months. Okay, so we see the amount just based off looking at these intercepts. We see the amount of feed that these animals will consume will increase going into the summer. Okay, so animals placed in the summer will just on average eat more feed than animals placed in December. And then going into fall, it starts decreasing again, and into September, it decreases so that by again in September, we're at the lowest point of feed. So body weight at initial placements, an important factor, and then season when the animals are placed on feed is an important factor. So this season that animals are placed on feed, if we think that an animal is going to be placed in December, they're going to be their heaviest in those summer months, okay, when the temperatures are hot, okay? Heavier animals will respond worse to hot temperature than lighter animals, okay? They just have a lot more insulation through that fat, okay? Compared to an animal that's placed on feed in the summer months, when they're their heaviest, okay, it's going to be in those cooler months of the year, okay? So they do better and will eat more feed whenever they're heaviest is aligned with cold temperatures. Make sense? Okay. We see a similar impact on average daily gain. Okay. Animals placed on feed will have the lightest average daily gain if they're placed in kind of like the fall. Okay. Um, really, their lightest December through July. Those intercepts weren't different. No, excuse me. Lightest or least amount of average daily gain September through October placements, and then uh, have more faster rate of gain if they're placed on feed November and December. Okay, because we see that kind of interaction between intake and average daily gain, we see a different responses based off placement months for feed to gain. Okay, so animals that are placed in those cooler months will have an improved feed to gain, okay, compared to those animals that are placed on feed in hotter months. That should make sense for all the reasons that we've talked about. If they're eating less feed, they're going to have lower energy intakes, okay? They're going to have less fat composition within their gain, okay? Less fat within their gain, more lean gain, so they're going to be more feed efficient. Okay. Um, okay. We've already said this. A lot of this impact of placement body weight on dry matter intake is going to be due to just them having a bigger average body weight over that whole feeding period. But a portion of that increase in dry matter intake, increased dry matter intake by heavier cattle is going to be they just have more gut capacity to consume feed. Okay. So this is some old data published by Hicks in 1990. They looked at 3 years worth of data from 1983 to 1985 from that Hitch feed yard in the Panhandle, Oklahoma. So they had 2,000 pens, 145 steers per pen for just under 300,000 head of cattle. Okay. Lighter cattle at receiving, same story as what we saw in the Kansas State Feed Focus on Feedlot report. Lighter cattle at receiving will never consume as much feed as heavier cattle at receiving. Okay. And then again, there's a huge impact based off of season. Okay. So March, May, July, September through May. Okay. Okay. Here's another paper published in 2023, but similar approach. They took closeouts from feed yard in the Panhandle of Oklahoma over a 6-year period. Okay, so panel A is for steers, panel B is for heifers. Again, the take-home cattle placed on feed at a lighter body weight just do not have the gut capacity to consume feed like those heavier animals when they get placed on feed. Okay, so they're always going to have a lighter intake than animals that are placed on feed at heavier body weights. Okay, so season effects on dry matter intake. Okay. Based on this Hicks paper, dry matter intake peaked in late fall. So this is not based off their placement body weight, but this is just how much feed was consumed on average by these cattle by season. So in late fall, October, and November, they saw a highest amount of dry matter intake. Okay. Cooler weather, cattle are going to be able to eat more feed. Okay. Hotter weather, they're going to come off feed, not eat as much because they're wanting to decrease the amount of heat from fermentation. Okay. So they can help maintain their body temperatures. Okay. Dry matter intake reaches a minimum in February. Okay. Then peaks again in May and June. So we saw this here in this Hicks paper, but we're also seeing something very similar based off placement month from that Kansas State Focus on Feedlot report. Okay. So with that, we'll end this. Key takeaways from those last few slides would be heavier cattle are going to consume more feed when they're placed on feed than cattle that are lighter when they're placed on feed. Okay. 2 reasons: greater average body weight while they're on feed. That's one explanation. But the other is around gut capacity. So heavier animals placed on feed, those that went through a stalker or grazing system, prior to being placed on feed in confinement, they're just going to have greater gut capacity. Okay. Okay. Switching gears. Okay. We're going to talk about feed bunk management, and a lot of this is going to be focused on feed calls. Okay. So I want you to be able to describe and define basically what feed bunk management is. Okay. I want you to know the benefits of using what's called slick bunk management as opposed to just ad libitum feeding. Okay. So how does it reduce cost of gain to use a slick bunk protocol, which may restrict intake as opposed to just feeding them as much as they want, ad libitum? Okay. I want you to be able to describe the bunk scores and the bunk score system. There's variations of these that a lot of people will use. Some will do it as 0 through 4 basis. Some will say slick, crumbs, lots minus, lots plus, but they're all really kind of the same thing. Okay. Know what information a feed caller will use. So what 3 pieces of information they'll integrate when they're making their decisions around feed calls. Okay. And then be able to appropriately fill out a table that would outline a cut and recover program. Okay. So took this protocol from my buddy Jarrett. I'm wearing his hat actually. But if you are reading bunks one day, you make a feed bump increase in feed call, and then all of a sudden the next day you go and read bunks and they have lots. Okay, so how do you recover from that? Make them clean up that feed that you delivered the day before, and then get them back to eating what they were previously. Okay. All right, feed bunk management. A lot of this presentation will be based off of this extension paper out of Iowa State by Lundy. Says I've uploaded this to Canvas. I may upload a link, but Canvas and their new accessibility rules doesn't really let me upload PDFs, so I may upload a link. And some of this material is based off of Pritchard. He was out of South Dakota State. And Burns, they published a paper, kind of a review paper in the Journal of Animal Science in 2003. Okay. Some of the examples are taken from my friend Jarrett Proctor, okay, consulting nutritionist. Then getting into the actual information. So if we think traditionally, whenever I say feed bunk management, you may just think about, so the approach, it refers to the approach to deliver feed for confinement animals, okay? These has to do with quantity of feed, timing of feeding, and this will be a lot of the focus of today's lecture, okay? However, we need to expand this definition to think about all things that relate to how that feed is being presented to these animals, okay? So, some issues beyond just amount and timing of feeding, some issues are pretty obvious, right? If we have manure in a feed bunk, that's really related to feed bunk management. That's something that's pretty obvious, right? However, what if the rollers on our flaking mill have widened and we're not adequately processing the steam flake corn that we're trying to feed? Okay, that's something that's a little less obvious, but still is related to feed management, feed bunk management. Okay. Okay. So Lundy defines feed bunk management as the way that we deliver a consistent, nutritious, fresh ration in a manner designed to optimize dry matter intake and minimize feed waste and spoilage. Okay. So this includes feed delivery, feed mixing, feeding a balanced ration, the quality of the feed, feed characteristics, so how palatable is it, the processing of the grain, processing of the forage, feed processing, and then other factors related to feed presentation. So bunk space allotment, health management. Sick animals aren't going to perceive that bunk where we're delivering feed adequately, right? They're going to not eat as much. So health management of the animals is important. And then also pen conditions, okay? So if we have excessive mud, okay, especially right there on the apron in front of the bunk, that's going to depress feed intake. Okay. All right. Pritchard and Burns defines it as encompassing the process that includes feed, batching, and delivery in context of quality, quantity, and time. So they state that bunk management has to be dynamic in process to type of diet, class of cattle, changes in climatic conditions, and bunk space allocations. Okay. What I think both those definitions have in common, and what I would want you to be able to know for the exam, is that feed bunk management is related to feed presentation to the animal and feeding timing. Okay. Um, so this presentation is related to, I didn't finish that, but really how that animal is going to perceive that ration that we're feeding. Okay. And then the goals that I want you to know for feed bunk management are to maximize dry matter intake and subsequent average daily gain, and we want to minimize feed wastage. Okay. So the goal of appropriate feed bunk management is to reduce cost of gain. Okay. If we have a lot of feed that gets wasted, that's going to hurt our conversion. How much conversion can we expect from feed that an animal's not consuming, that we have to throw away in the manure pit, right? Zero. Okay, it's undefined. They will gain no pounds off of feed that's not consumed. So that's just literally a waste of money and is increasing our cost of gain of these animals. Okay. So this is kind of cool. All right, feeding cattle and feed bunk management, I would say, is really more of an art than a science. Okay. Pritchard and Burns, they suggest that research on bunk management is extremely difficult, some cases impossible, because there's a lot of confounding factors, right? What the decision I make may be different than the decision you make or the other person's, right? Because it's a subjective call, right? You have to integrate bunk signs with cattle signs with your historical knowledge, okay? So it's a very subjective process. However, it's not new, okay? So Henry and Morrison in 1928 in their Feeds and Feeding book, they stated that many inexperienced stockmen can carry steers through the fattening process without once getting them off feed, but yet cannot well describe to others just why he or she is so successful, okay? So it's a subjective process, and they were saying this almost 80 years ago, okay? They also said this, which I think is a cool little quote, but the eye of the master fattens his cattle. Okay. So that would suggest a certain level of feed bunk management and feed calling were even occurring here in 1928. Okay. Even older, Mumford in 1907 in his beef production book. I'm trying so hard to get a copy of this book because I love old books, but they're very expensive. So he says, as soon as the fattening process begins, cattle should be fed at certain hours and in the same way. This cannot be varied by 15 minutes without some detriment to the cattle. That's a rule of thumb that people still use quite often today. Okay, we want to be plus or minus 15 minutes of feeding cattle around the same time. Okay, the extent of injury will depend upon the frequency and extent of the irregularity. Okay. So that's kind of a still common theme of things that people believe today. Hard to study, hard to put numbers behind it, but a lot of people still use that plus or minus 15 minutes around feed delivery the same time of day, okay? And then the extent of injury will depend on frequency and how much irregularity there is, okay? So he also says, scourings, the bane of the stock feeder, should be carefully avoided since a single day's laxness may cut off a week's gain. We see that in our feed intake curves, okay? Something happens, causes animals to crash off feed. It can take a week or longer for them to recover where they were, okay? Overfeeding comes from a desire of the attendant to push cattle to better gains or from carelessness or irregularity in measuring out the feed supply. So the ideal stockman has a quick discernment, which guides the hand in dealing out feed ample for the wants of all. So this is all animals, but not a pound in excess. Okay. very true with the feed management that we're doing today. And this would suggest that in 1907, there was some level of slick bunk management. Okay? They probably didn't call it that. They probably didn't do bunk scoring, but the deal out ample feed for the once of all, but not a pound in excess sounds an awful lot like slick bunk management to me. Okay? Ad libitum feeding, so that would be unrestricted access to feed. Cattle are able to fully consume feed to meet their voluntary feed intake. So ad libitum could be considered true if we have a targeted residual or refusals or orts or waybacks of 5% each day. So in an experimental setting, someone would say cattle were fed ad libitum. We targeted to allocate enough feed that was 5% more than the amount of feed they ate the day before. Okay, so that's a common management to achieve ad libitum in a research setting. Okay, so cattle in today's feedlots, they are not fed ad libitum. No one's really feeding as much feed as that animal could possibly want. One, it's kind of risky to feed cattle high energy diets ad libitum, as it could allow increased likelihood that that animal will have a gorging session. Okay, so when I say gorging, it just means one errant day they walk up to the feed bunk and eat a lot more than they normally do. Okay, that increased slug of feed into their rumen can cause ruminal acidosis, can cause digestive upsets and disorders. Okay. Then, if we targeted 5% refusals, that would mean they're only consuming 95% of the feed that we offered, right? So, a 5% additional feed cost and increased feed waste would happen. So, no one's really feeding cattle ad libitum. Most people are implementing slick bunk management. So, slick bunk management aims for feed delivered to equal feed intake. So, we want animals to consume all the feed that is offered to them. Okay? So we target a zero or slick bunk right before feeding, reduces feed waste relative to a true ad libitum management, can improve feed efficiency. Most studies would suggest 2 to 3% improvement in feed efficiency. Okay. The downside is that if it's not properly managed, if you're not increasing feed calls like you should, then you may be restricting dry matter intake, and therefore you could hinder performance. Okay. Okay. However, most studies would suggest that adequate management, adequate feed calls, and bunk reading can overcome this limitation. Okay. All right. So this is the South Dakota State bunk scoring system developed by Dr. Pritchard. So that's the same guy from Pritchard and Burns. Okay. Their recommendation is you go and you physically look at the bunks. Maybe you're riding in a truck, okay, and you're recording a bunk score for every bunk in the feed yard, okay? These scores are either zero, which means they're slick, there's no feed left in the bottom of the bunk, okay? Half, some people may call these crumbs, okay? So that would be a scattered feed present. Most of the feed in the bunk, or most of the bottom of the bunk is exposed. So when you look at that bunk, you see just maybe a little crumbs of feed, but you're seeing mainly concrete, okay? You can have lots. So lots minus would be 1. So this would be a thin, uniform layer of feed spread across the bunk, usually the thickness of 1 kernel of corn, okay? 2, so this is just lots. 25 to 50% of the previous feed delivery is remaining. 3s, so lots plus. There's a crown of feed, though it is so whenever you dispense feed from a wagon, it'll kind of make this crown, this pointed part where it piles up, right? Think like when you're piling up sand out of a clock, or what is it? Those things called? Hourglass, right? Whenever that sand falls, it leaves that kind of crown at the top, okay? So the crown of the feed is disturbed, so that means that that's an indication that cattle were at the bunk and actually eating, right? But there's more than 50% of the previous day's feed remaining, So that'll be lots. Okay. Then we can have 4, which is again lots, but that crown of the feed in the bunk is not disturbed. So this would suggest virtually untouched. This would suggest some amount of eating, but still a whole lot of feed left in the bunk. Okay. Okay. This is taken out of that Lundy paper. So most of this bunk, if not all, is slick. Okay. Something else you could look for when you're reading bunks is that could indicate the timing of when that slick bunk occurred. Are there lick marks at the bottom of the bunk? If there's still wet saliva patches where cattle went and were physically trying to eat that feed, that would indicate that it became slick at much more recently. However, if it's slick and dry, that would indicate that they've been slick for, longer hours. Okay. So this would be an indication of a half. Okay. This is a 1, and then that is lots. So you can see the crown of that feed was disturbed. Some level of consumption occurred. However, there's still a whole lot of feed left in that bunk. Okay. Yep. One last thing. So let's say like your diet is composed of some kind of real inedible roughage. So like a corn stalk or sorghum stalks. I won't, oftentimes, if that's kind of all that's left, some corn cobs, some corn stalks, kind of at the bottom of the bunk, I would still call that slick. So it's kind of, again, it's at the discernment of the bunk reader. Okay. All right. This study conducted by Bierman and Pritchard, so that same Pritchard that established that 0 through 4 scale, they compared slick bunk to ad libitum feeding. The slick bunk was actually slick 69% of the time. So that means 31% of the time there was still some level of feed left in the bunk. And uh, and then for the ad libitum treatment, it was slick only 39% of the time, or 40% of the time. So that means 60% of the time there was still feed left in the bunk. Okay. But that also means 40% of the time, even though they aimed to have feed remaining in the bunk, those animals still cleaned it up. Okay. All right. They found no difference in average daily gain or final body weight. Okay. Ad libitum had 12% greater dry matter intake. Okay. But that 12% greater dry matter intake is not based off of amount of feed fed and amount of feed refused, right? It's just feed delivered. Okay. Does that make sense? Okay. So that means that would kind of indicate that maybe 12% of the feed that was delivered was actually just wasted. Okay. Because they were targeting feed remaining in the bunk at the end of the day. Okay. Since there was no difference in average daily gain and they had 12% greater dry matter intake, they had 12% greater feed to gain. So that's 12% worse feed conversion. Okay. Saw no effect on carcass, except the slick bunk tended to have more marbling. Okay. Don't know if that's real or not. And then the slick bunk managed had a lower cost of gain and a lower break-even sell price because it had less feed waste. Okay. Questions so far? Is this all clear? Okay. All right. More recent paper, Smock in 2021, they did a 2x2 factorial. So 2 treatments were fed ad libitum, 2 were fed slick bunk. Then the slick bunk, they targeted a 0 at 7 in the morning. Okay. The ad libitum, they targeted a 1 at 7 in the morning. Okay. Then the other 2 factors were around flake density. So they had 26 pounds of flake weight per bushel versus 33-pound flake weight per bushel. Okay, so what would a more dense flake weight indicate? So this is from steam flake corn. So if you can have a would a 33-pound per bushel flake weight be more processed or less processed than a 26-pound per bushel flake weight? which I forget which way I asked actually. Okay. Yeah, 33 would be less. The denser they are, the less processed they are, the less starch availability there is. Okay. So that means that the lighter flake had tighter rollers coming out of the steam chest and had more processed, so more starch availability compared to that heavier flake. Okay. All right, so ad libitum was scored on target, so they had a 1 just under 60% of the time. They scored a half, 19% of the time, and then 2 for 3% of the time. Okay. Slick bunk was on target 55% of the time, so that means they had a 0, 55% of the time, had a 1, 21% of the time, a 1.5, 22% of the time, and then 2, 2% of the time. Okay. Um, Refusals, aka orts, aka waybacks, were collected from each pen each day, and then they calculated dry matter intake based off of offered, offered minus refused. Okay, so they were actually measuring dry matter intake instead of that previous paper, which looked at just feed allocated. Okay, all right. So they used orts to calculate dry matter intake. This is important because they didn't use offered as the indication of dry matter intake. Okay. They also didn't report how much waybacks there were between the two treatments. So we have no indication of if the ad libitum, how much feed waste that ad libitum management had. Huge flaw in the paper, in my opinion. Okay. So I'm assuming, based off bunk scores, the ad libitum treatment had more feed waste, right? They had more of those ones, more halves, and more twos. Okay, bunk scoring. Okay, so they stated the average daily feed carryover was 8% of offered for ad libitum treatment. Okay, so that means that would suggest an 8% of offered feed waste. Okay, and that it was only 1% for the slick bunk treatment. So they found that bunk management had no impact on dry matter intake, average daily gain, feed efficiency, or carcass characteristics. Okay? The results indicate that using slick bunk management achieves similar growth and carcass performance with presumably less feed waste. However, they don't exactly tell us that. So if we considered all feed delivered in that feed to gain calculation, the ad libitum treatment should have a worse feed conversion because they would have more waste. Okay. So in essence, is that what I say here? I think that's what I say there. Okay. So we'll move on. Okay. Bunk reading. Okay. Feed calls are made prior to feeding. Typically, they will have that bunk reader drive around 30 to 45 minutes before feeding. They will be physically driving around. They'll start their first bunk while they start mixing the feed, okay? And then they try to keep 30 to 45 minutes ahead of the feed trucks, okay? They may do an intermediate feed call between feedings. So let's say, like we just looked at, if you have 3 drops, they may go around and do an intermediate feed call between the drops, okay? Particular between the second and third, or if you're doing 2 times a day feeding, between 1 and 2. Then, based off of their intermediate feed calls, they may make a feed call adjustment for the subsequent feedings, okay? If they're going around and they read between the first drop and the second drop, they may say there's a whole lot of feed left here. Let's decrease the amount of feed delivered in the second or maybe third drop, okay? Most people don't do that though, because you end up just kind of chasing the cattle all around in terms of what they'll actually eat, okay? So you may end up doing more harm than good by doing that, okay? Okay. So reading bunks at close to the same time each day is very important. Okay. So you want this scoring system that you're using to be consistent from day to day so that the feed calls, so bunk reading is going around making the scores. Feed calls is actually determining how much feed you'll want to deliver to the animal. So you want your bunk scoring to be done the same so that your feed calls can be consistent. Okay, you want to compare apples to apples throughout the day. Okay, they will record this typically in a digital program. Okay, so this is performance beef. This is one example of what people will use. So as they go around, um, uh, they'll make their bunk score, and then they'll estimate how much pounds are left in the bunk, and then there they'll make their feed call. Okay, so typically they're doing this in real time on their computer system in the truck. Okay. Uh, okay. In Bushland, at the research feed yard I worked at, we would make these feed calls on paper, and then we go back to the office and make the feed calls prior to feeding. Okay, but we were feeding 350 head as opposed to 50,000, right? So we could do that. The bunk reader can then make the feed calls in real time. Program actually have you enter like slick, crumbs, or some estimate of feed remaining. Okay. So instead of that 0 to 4 scale that we just went over. So this program, Performance Beef, you'll say, click on this drop down. You can select slick, which means 0, crumbles, which is crumbs, or they estimated this pen to have 50 pounds of feed left remaining in the bunk. Okay. Okay. So enough about bunk scoring. Okay. Uh, Here is a rule of thumb that a lot of people will use. So it's called the third rule of thumb. Okay. So when they're driving around and looking at cattle, at the time when the feed truck arrives to deliver feed, they want a third of the pen at the bunk actively eating. Okay. They want a third of the animals in that pen to be starting to get up and acting interested in making their way toward the bunk. Okay. And they want a third of the pen animals to be not interested. Okay, so hanging back, loafing around at the back of the pen, not actively interested in the feed delivery. The rule of thumb is if you have met these conditions, you're ideal on where you want to be in terms of feed allocation to those animals. Okay, they're at a good point in their dry matter intake curve. Okay, they'll also check feces consistency. Okay, overly runny feces, and I have some examples of this, would indicate ruminal acidosis. Okay. Real solid feces may mean that they're coming off feed, not eating as much. Okay. So we'll look at feces consistency. So, in essence, a successful bunk reader and feed caller will integrate these bunk scores and animal behavior signs. Okay. So, even if bunk scores are 0 3 days in a row, if animal signs are indicating that they're not aggressively coming to the bunk, you're still at your third rule, okay? And the feces is runny, indicating that they have ruminal acidosis. Even if they have zeros 3 days in a row, they may not increase that feed call, okay? Yes. I'm guessing all the time. Um, if you remember to Tuesday, we had the ideal intake curve, and I showed some examples of actual intake curves. We're never at the ideal. You always have cattle coming off feed, right? Having crashes in intake and it taking a long time for them to catch back up. What's causing that? You don't really know unless you're keeping records on feed calls and bunk scores. But even then, a lot of that could be you have a guy loading the feed truck and he overloads steam flake corn by 300 pounds. Okay. Rather than going in and scooping out 300 pounds and putting it back into the payloader, he lifts up on the scale and then hits record whenever the scale says 0 to say that they're on target with their feed ingredient. Okay. So now we have a ration instead of 70% steam flake corn, it could be 80 or whatever. Who knows? Okay, just as an example. So now we have a much more energy dense diet than what those animals are acclimated to. Okay, so these types of things happen all the time. We're going to have Jarrett give a guest lecture. I think it'll be the Tuesday after PNC, the week after PNC. So I don't remember what day that is. But he's going to give a guest lecture, and you'll find that 90% of what he's talking about is people management. Okay. 90% of what he does is not actually formulate rations. It's go and teaching people to do things correctly. Okay. So yeah, these types of things happen all the time. Okay. Manure, so really we're talking about fecal scoring, okay, but manure scoring is a visual assessment of the feces, and we have a score of 1 to 5. So 1 is being very liquidy and runny, so poor, indicating acidosis, okay. 5 would be stiff, dry balls, so what you would expect to see in cattle that are consuming a dry hay diet, okay. In this scoring, too low is bad, too high is bad. So the ideal consistency is somewhere around 3. But in a feedlot situation, even a 2 could be okay. Okay, so good morning. Here's some pictures of feces. Okay, so manure score of 1, very liquidy, runny, shallow puddles. As soon as it hits the surface, it kind of goes out like a lake. Okay, manure score of 2, manure does not pile really high, and it will spread out some, but it will stand by itself up to about 2.5 centimeters high. Manure score 3, so this would be the ideal consistency for a lactating cow. Thick, custard-like. You guys may never eat custard again, okay? And would stand about 4 centimeters tall, and then it forms these concentric rings around the center, and it will not stick to your boot, according to this scoring system. So manure score of 4, ideal consistency for like dry cows or in-calf heifers. So this would be kind of drier, animals consuming drier diets. Okay. Then manure score of 5. This looks like horse feces to me, but very dry, hard balls. This is what you could throw at your brother, right? Okay. So in slick bunk management, the aim is to have, for most days, to be at a 0. Okay. You want an occasional, so 3 out of 10 days, you'd be okay with a bunk score at a half. So it kind of crumbs. You will cut offered feed based on scores of 1s or 2s, no matter what. Okay. You may cut offered feed for 1s if there's several days in a row where they have those crumbs left, and so they're accumulating. Okay. So you want to allow them to clean the bunks up, so to eat that refused feed so that you can cut down on feed wastage. Okay. So on halves, if there's halves for several days in a row, you may cut them a little bit, about the same amount of feed that's left in the bunk, to where that day they'll clean it up, and then you'll immediately add it back the next day. Okay, so it's just trying to cut down on feed waste. So this management allows people to achieve similar growth and carcass performance without, I think I forgot to finish my slide here, okay, but without causing high incidences of ruminal acidosis and erratic intake behavior, okay? Okay. Most commercial feed yards, some of the small farmer feeder types may not do this because they're strained on labor, but most commercial feed yards will have a night bunk reading, okay? Really good programs will do this. They'll do a night reading at 6 p.m., 9 p.m., and then if they kind of run into some issues where maybe you have an excessive number of bloats, they may do one even later in the night, okay? So colloquially, so word of mouth, no data will support this because it'd be very hard to measure. Most digestive disorders are caused by cattle slicking their bunk too early in the night. Okay? For example, if the animal is slick at 9 p.m., they will go approximately 8.5 hours without feed. So that first morning, when you first deliver the feed, they're going to come to the bunk real aggressive, and they'll have excessive gorging, right? They'll have a big slug of that finisher diet enter their rumen, cause pH to drop, okay, and cause bloat, acidosis, all these other things that we'll talk about. I think maybe next lecture we'll talk about ruminal disorders and dysfunctions. Okay. For smaller feed yards, still recommended to do this if possible. However, again, they're going to be strapped for labor. They're going to be strapped for time. They'll go in and feed these cattle in the morning, and then go and have to plant corn in the evening, right, or in the afternoon. So harder for these guys to do these kind of night calls, but still recommended. Okay. Bunk reading. So this is a subjective scoring thing. With the advancements of technology, there's a high potential to have some automation. Okay. So let's look at this. So these are robots that will go around. I'm sure it'll open 100 times. But robots that'll go around with cameras using computer vision and AI to actually assign these bunk scores. Okay. So here's an example. I think this is out of Australia, but it's an automated robot. Well, I don't want to do that. Okay. Automated robot, there's the camera, and it's going around and reading bunks for that feedlot. This isn't a YouTube video. Oh, here we go. So yeah, I think this is out of Australia. Yeah, definitely Australian.
Through previous alpha and MLA investments, we were able to successfully develop and validate an automatic bunk scanning system to help predict feed remaining in commercial feedlots. We're able to verify through extensive testing programs that the automated system.
Everybody get the idea? Okay. All right. So I think there's a big potential for automation. I think anything in the livestock industry where we have these subjective readings, so body condition scoring, we have a potential to use image processing and AI to take these subjective measurements and make them objective, right? So more consistent, less margin for error. So people much smarter than me are working on these types of things. Okay. And not being adopted in the US, but we still have pretty good access, relatively good access to cheap labor, right? Especially compared to places like Australia and the EU, right? So I think other countries will start adopting these much sooner, but eventually, 50 years, 20 years, I don't know, maybe we'll get there. Okay. So here's another example. This Precision Livestock Companies out of Dallas, they actually came out and installed some of these cameras at Bushland, some of these prototypes, but they have these cameras mounted on poles, and they'll have one over the water trough, one looking at the pen, and then one just looking at the bunk. And so at all times, since it's stationary, it's not moving pen to pen, but at all times it'll give a good reading on bunk scoring, how much feed's left. It'll give a good estimate of cattle activity. Do you have an animal that hasn't been to the bunk in a long time? Maybe we need to get somebody out there to investigate. Maybe they're sick, or if they're not drinking, maybe we need to get somebody out there to investigate. Okay. All right. So feed calls. So the person that's actually determining how much feed needs to be delivered. So that decision is called a feed call. Okay. So feed callers will consider bunk scores. So they'll always cut feed on a bunk score of 1 or more. They may not cut, again, a half, score of a half, unless it has built up over time and they want to get them to clean it up. Okay. Then they'll consider animal signs. So they'll hear this from the feed truck delivery guy. If there's good communications between the bunk reader, the feed truck driver, and this feed caller, they should be able to integrate animal signs, so fecal scoring and aggressiveness to the bunk. Okay. Um, so communication between these people are important. And if anybody's worked with humans long enough, you know that communication is always a struggle, right? So quite often, this communication is a big issue in practice. Okay. So they'll consider where those cattle are at in their feeding period. Okay. For example, you have an animal that's been on feed for a longer period of time, so they're later in their feeding period. Based off of your prior experience with similar groups, you know that they may be closer to their upper limit on dry matter intake. Okay. So as animals go and their duration on feed becomes longer, that intake becomes plateaued. Maybe you're going to be less aggressive with your feed calls, so your feed bumps as that animal progresses within that feeding period. Okay. Um, okay. Compared to animals that are uh, uh, just starting out on feed, maybe you know from previous experiments they have a long ways to go, and you know that based off of similar groups of cattle that you fed, maybe earlier in the feeding period you want to be more aggressive. Okay. Um, hmm. So, three main things that a feed caller will use or integrate when they're making their decisions: bunk scoring, animal signs, feces and aggression, and then historical knowledge. Okay, so that's where the science or the art comes in. Okay. All right. Recommendations: do not bump cattle, so increase feed calls more than every 3 to 5 days. So this is after cattle are up on feed and went through your transition program. Okay. So we will not bump until they've had shown us at least 3 days of slick bunks in a row. Okay. If you may have 2 days of slick bunks in a row, but if there's crumbs before that third day, they haven't met that criteria, and you won't continue to increase their feed call. Okay. Then do not increase feed calls more than 3/4 of a pound at a time. Okay. That's 3/4 of a pound per head. Okay. So if I have 100 head, I will not increase that feed call to that pen by more than 75 pounds of dry matter. Okay. So increasing could be half a pound to 3/4 of a pound, depending on when that that slick bunk, depending on when that slick bunk occurred. Okay. So if they slicked up in that evening time, maybe I'll bump them 3/4 of a pound per head. However, if they slicked up just before morning feeding and they had lots or even crumbs in the evening, okay, maybe I'll just be more conservative and only bump them a half a pound a head. Okay. So it should be very obvious to you guys that you have to track these changes over time. Okay, you have to have multiple days of feed calls in a row to make your decision. And so record keeping becomes immensely important. Most, all, except for the AgriLife Research Farm in McGregor, will have a computer software program to do this. A lot of people use Performance Beef. A lot of people use Digistar, will have one. And then there's a bunch of others. Okay. But they will have some kind of computer program to make this record keeping more streamlined. McGregor, the A&M research feedlot, does not have that, and they're all paper records, and it drives me nuts. Okay. We had Performance Beef there at Bushland. Okay. Then at Oklahoma State's research feedlot, we had Digistar. So, um, okay. So messing up feed calls can have long-lasting impacts. Here we have two pins, pin A, pin B. Okay. If you mess up cattle early, you'll probably be battling these animals for the rest of the time that they're on feed. Okay. So this figure is from the Lundy paper, so that paper that outlines the bunk scoring system. Okay, they had two pins that were fed similar rations. Okay, pin B, so this dashed pin, experienced some kind of perturbation here around day 8. You can see they developed some sort of malaise, probably some kind of ruminal acidosis. that caused them to crash off feed, okay? And then they never regained compared to what pen A was eating, okay? And they were also way more volatile in their day-to-day intake compared to pen A, okay? Um, so also you can look at the difference between the amount of feed these two pens consumed. Which one do you think performed better? Should be pretty obvious. Pen A ate a lot more feed. Chances are they had better average daily gain. Chances are pen B is a loser, right? Probably lost some money for these people, especially relative to their opportunity cost, which was presumably be pen A. Okay? So, what caused this to happen? If you don't keep records, you really don't know. Then, on the other hand, if you don't investigate and look at your closeouts, you also won't know. Okay? Okay. So, guys, remember from Tuesday, how am I doing on time? 15 minutes. Okay. Tuesday, we want to maximize intake, and assumably, if we maximize intake, we're going to maximize average daily gain, okay, without causing substantial crashes, okay? So a crash in intake can occur due to things out of our control. Barometric pressure. Cattle will not eat as much feed if a storm front comes in, okay? Uh, excessive shifts in temperature. Okay, if you go take an animal from thermal neutral, and then one day you have all of a sudden an increase in ambient temperature, okay, they're not going to eat as much. So there's a lot of things that can impact feed intake by animals that we can't control. But what we can control is our feed calls and our bunk management. Okay. Um, so things that we can control is to not overfeed animals. Okay. You'll hear people say getting over the top of them, okay, in their feed calls, where they maybe were too aggressive in a feed bump, okay, cause those animals to one day have a gorge of this high energy finisher ration, causes their ruminal pH to decrease, causes them to feel bad, so that the next day they don't eat as much and they leave feed in the bunk, okay? So cattle overeat on one day, they experience malaise, so that could be caused by low ruminal pH. That feeling of sickness makes them not eat as much the next day. So you have cattle go off feed, leave refusals. Okay. So overfeeding could occur from feeding more than the feed call. Okay. So maybe you as a feed caller are doing right, but that feed truck delivery guy messed up and actually delivered 100 pounds more feed than what he was supposed to. And instead of getting out of the truck and scooping it back into the feed truck, he just leaves it in the bunk. Okay. So this is what we saw here in this intake curve. So went back to the records. Why did this group of animals that were doing okay, why did they have this big decrease in feed intake? Went back to the records and they overfed by about 5 pounds per head, okay, as fed. And it took just about a week for them to get back to where they were, okay? Oh, here's the story. Day 72, truck driver underfed by 0.3 pounds. Day 73, truck driver underfed by 0.21 pounds. Feed caller bumped the cattle by 0.25 because they had slick bunks 3 days in a row. Little did he know they were being underfed relative to his feed call. Okay. Day 74, truck driver overfed by 0.36 pounds, okay, per head. And so that would actually increase the feed that was offered from day to day by 1.12 pounds per head. Okay. So day 75, feed caller cuts them by 1.5 pounds of dry matter per day. So that's here. And they never took a long time for them to recover. If we were to draw a line between these 2 points, that is lost intake and lost conversion into average daily gain. So how much money did this incident lose by cattle or by the truck driver not delivering the correct feed calls and the feed caller not considering that? I don't know, but it could be substantial, especially if you consider maybe the same thing happened here and here as well. Okay. All right. So you're a bunk caller, you're driving around, you're reading bunks. all of a sudden one of your bunks has lots. Okay, what do you do? So the goal on these cut and recover protocols are to regain intake to the amount prior to the cut. Okay, so by cut, I mean I'm going to decrease my feed call so that the amount of feed that we're offering to these animals is less. So cutting the feed call. Okay, the rule of thumb: the further you from the cut that you get, the less likely animals will recover that intake. Okay, so the longer it takes you from that period of time where you cut their feed call to regain the previous feed call, the less likely that animal will ever consume that much feed again. Okay, you're conditioning those animals to eat less feed, in essence. Okay, but you don't want to be super aggressive and further cause issues, right? So here, day one, you read bunks, there's feed in the bunk. Our feed call needs to be a double cut. So we're going to cut double the amount of feed that's left in the bunk. Okay, and I'll walk through an example in the next slide. Day two, we have a slick bunk. We're going to give half of that cut back to those animals. Day three, we have a slick bunk. We're going to give a quarter of our initial cut back to those animals. Day four, we have a slick bunk. We're going to watch them. We're going to observe. Okay. Then day five, we have a slick bunk. We're going to give a quarter back, and that should get us back to that initial cut. So here, I think this next slide will be an example. Okay. Sunday, feed delivery was 6,000 pounds as fed to pin one. On Monday, we go through, read the bunk, we assess, based off our visual appraisal, there's 500 pounds of feed remaining. So that means that day, from Monday to or Sunday to Monday, that means those groups of animals, we offered 6,000, they left 500. So how much feed did that animal eat? 5,500 pounds as fed. Okay. So our feed call for that Monday is to do a double cut. 500 times 2, we're going to cut 1,000 pounds off of that feed call. Okay. Remember, so that means we're going to feed 5,000 pounds. Okay, but remember there's 500 pounds left in the bunk. So how much feed is left? Do we actually have in the bunk? 5,500, which is how much they ate Sunday to Monday. Okay. Tuesday we come through, we read bunks. They're slick. Okay. So that means the cattle have now consumed 5,500 pounds 2 days in a row. Okay. So our feed call, we're going to give half back. Okay. So we cut 1,000. We're going to give half of that cut back. And so now again, there's going to be 5,500 pounds of feed left in the bunk. Okay. So we offered 5,500. So this is the same amount that they consumed from Sunday to Monday and then Monday to Tuesday. Okay. Wednesday, we see a slick bunk. Cattle have now consumed 5,500 pounds 3 days in a row. So that's 3 days of the same intake. Cattle are ready to try to increase that feed. Remember, the goal was to get them back to 6,000 pounds. Okay. So our feedback call, we're going to give them a quarterback. Okay. Not the football quarterback, but a quarter of that initial cut. So we're going to allocate 250 pounds. So we're going to offer 5,750. They had 3 days in a row of 5,500. Now we're going to try to challenge them a little bit, start trying to get back to that 6,000 pounds by giving them an additional 250 pounds as fed. Okay? So on Thursday, we observe, we just bump them. We don't want to get super aggressive and have 2 days of bumps in a row. So Thursday, we're going to observe, and we're not going to increase the feed call. Friday, they're slick again. Cattle have now consumed 5,500 pounds 3 days in a row. Okay. They have also consumed 1 day of 5,750. Okay. So we're going to give them another quarter back of that original cut. So that's an additional 250 pounds. So we're going to take them 5,750 to 6,000. Okay. And so now we are offering 6,000 pounds. Okay. So we're back to where we were. Red bunks, all of a sudden we have lots in the bunk. So we cut, double cut, and then follow these procedures to recover that initial level of intake. Okay. So it took, 5 days to get back to that 6,000 pounds of feed. Okay. During this time, Um, so we don't want to be over challenge, okay? So if signs of bunk scores or cattle behavior or feces consistency are indicating that they're not ready for the bump, even if they're slick, maybe we won't increase it, okay? Um, so maybe we'll offer less feed on that recovery period. Maybe we change our expectations, and instead of trying to get them back to 6,000, maybe they need to be at 5,750 anyways. Okay. So if at any other day in this protocol there are refusals again, we need to start the process over. So double cut, give half back, give quarter back, etc. Okay. So when we're doing this, they're not going out there and scooping feed out of a bunk and weighing it, right? So all of these decisions are made off visual appraisals. Okay. So what if my visual appraisal of 500 pounds was wrong? Okay. So we go back the next day and there's 250 pounds left. Well, then we can just start the process over, um, and until we kind of get it right, until they start achieving slicks. So we'll continue that double cut until we start seeing them leave slicks in their bunks. Okay. So we'll say bunk readers will have a pretty dialed in eye on relating volume of feed to pounds of feed. They do this all the time, hundreds of pins. Over time, you just get good at it. They'll be much better at these kinds of guesses than me, and certainly better than you guys. Okay. So as you get experience, you're going to get much closer to your guess. So if we say that a finishing diet is 65% dry matter, and we fed to a pen of 180 head, so consuming 5,500 pounds as fed would mean that they're consuming 19.9 pounds of dry matter per head. Okay. A 500-pound visual assessment of refusals would mean 325 pounds of dry matter is left in the bunk. So that would be 1.8 pounds of dry matter per head. Okay. So let's say instead of 500 pounds, there was actually 450. So we were off by 10%. We were off by 50 pounds. Okay. So that could be 10% over or underestimated. So based off that visual appraisal, if we do that math, that only amounts to plus or minus 0.18 pounds of dry matter per head. So only less than 1% of daily dry matter intake. Okay. So it just goes to show, I'm showing this as a point that even if you're off by a relatively large amount in your feed call, because there's such a large number of animals in these pens, it amounts to a very small amount of actual feed allocated per head. Does that make sense? Okay. If they're off appreciably, cattle will tell them based on the next day's feed bunk scores when they, if you way overcut, they'll be slick in that evening, so you know that you overcut. So maybe you would include that in your decision making for the feed call the next day. And if there's feed left, you would just start the cut and recovery protocol over until you achieve that kind of slick bunk that next day. Does that make sense? Okay. This is an example of something that'll be on your test. Okay. So it's a very similar scenario. This is day, this is bunk score, this is amount of feed remaining. Here's the feed call as fed, what you're going to feed. Okay. And then this is the actual amount of feed that's consumed. Okay. So day 1, 2, 3, okay, 4, you go through and they have bunk scores of 0. Remember that this bunk score is actually how much they consumed the day prior, right? Um, all of a sudden, day 5, you have a bunk score of 1. You estimate that there's 250 pounds of feed left in the bunk. Okay. So how much did they actually consume? 250. So 4,250 minus 250 is 4,000. So your feed call for that day is to double cut. So 4,250 minus 500 is 3,750. This next day they have a bunk score of 0. So they've had another day of 4,000 pounds. Okay. So the question for the exam would be, what would you do to fill out this table? Okay. And the answer is there. Okay. So, double cut from here to here, then give a half back. So give 200, half of 250, so 1250 back so that they have 3 days in a row of 4,000 pounds. Then you give double back again, so 4125. They actually consumed 4125 because our bunk score was 0. Okay, we're going to hold them. So that's going to be 2 days in a row of 4125. And that next day, we have a bunk score of 0. They've had 3 days of consuming 4,000 pounds, 2 days of consuming 4,125. So we're going to give a quarter back again so that this amount that's offered is back to where it was before the cut. Does that make sense? Okay. Okay. So, conclusions, bunk reading and feed calling is highly subjective. Like with all subjective activities, it can be more of an art than a science. The decisions that I make may be different than the decisions someone else makes. Okay. So successful bunk reading and feed calling would need to integrate bunk scores, animal signs, and past experience. I've said that a lot now, so remember that. Okay. And then it blends really know-how with art and science. Okay. I think that's it. Good work, guys.